Physiology. I'm your host, Morgan Epikaizo Gama Jr. Okay, so for today, we shall look at the body fluids as well as the electrolytes balance. So on the learning objective, we need to know the distribution of the body fluids and composition of the intercellular and extracellular fluid. We need to know how to calculate the volume of the different fluids compartments. And also you need to know how to calculate the shift in the osmolarity. And we need to define what osmolarity is. Then we should also be able to define what tonicity is and the Donan effect. Okay, so without wasting much of your time, we'll quickly look at what homeostasis is. What is homeostasis? Homeostasis is just the maintenance of the relative stable internal environment. That is what homeostasis is. So in homeostasis, we get to have the maintenance. We have the cell, the body system, as well as homeostasis. So the body system maintains homeostasis, and homeostasis is essential for survival of the cell and the makeup of the body system. Now, so if we look at the diagram that we have here, we have the digestive system where nutrients as well as the salt water and also the respiratory system, the internal environment and the external environment. So the external environment, we're getting oxygen and carbon dioxide. So we're getting oxygen in from the external environment and giving out carbon dioxide through the respiratory system. And then we have the heart pumps blood, where the blood cells plus the plasma. And then we have the digestive system where we're getting nutrients as well as the salt and water from the external environment, take them into the internal environment for absorption of matter as well as other organic nutrients. Okay, then we have the urinary system where we have the kidney, the bladder. Okay, so this is where we get to have the excretion of urine, as in the waste product. Now, if we look at here, we have an organism in homeostasis. So if an organism is in homeostasis, it has two important key factorial. We have the external change as well as the internal malfunction. So external change and the internal malfunction, which leads to the loss of homeostasis, resulting into the response attempt to compensate. That will now lead to what we call compensation fails, or rather compensation proceeds. So if the compensation fails, it results into disease or an illness. But if compensation succeeds, it results into wellness. Now, how are they in balance? That is homeostasis. So in homeostasis, we need to ask ourselves this question to say, are the salt water, glucose, and all the nutrients that are needed by the body, are they in balance or homeostasis? Now, water balance. So under water balance is the table, that is table 25.1. It shows the daily intake as well as the output of water the meal per day. So the normal intake, so we have the intake, the normal, as well as the prolonged heavy or rather exercise. So the intake fluid, the fluid ingested, normal we need about 2,100 mils per day, and from metabolism we need 200 mils per day, and total we need about 2,300 mils per day. Then the output, that is insensible skin, like through sweating, move about 350 mils per day. Then insensible lungs, usually it moves about 250 mils per day. Then sweating, 100 mil per day. Then through the feces, it's about 100 ml per day. Urine, it goes up to 1,400 ml per day. Then also the total goes up to 2,300 ml per day. So this is the daily intake as well as the output of water per meal per days. Okay, so the body must maintain the relative constant volume and composition of the body fluid under a wide variety of conditions. Now let's look at the role of water. So the role of water in the body. Water plays an important role in the body. Number one, for temperature regulation. Number two, for protective cushion. Number three, for lubrication. Four, for reactants. And five, for solvents. Six, for transport. So if we look at the chemical composition of water, water consists of hydrogen as well as oxygen atoms. Hydrogen as well as oxygen atoms. Then we have the chloride as well as the sodium ion, the chloride ion as well as the sodium ion. So these ones, they help out into the water retention as well as maintaining the water levels in the body, that's under osmotic regulation, and also thermal regulation, maintaining the body temperature. Percentage of water in the body. Okay, so percentages of water in the body, in male, it's about 60 to 65%. Then in babies, it's about 70 to 73 to 80%. In an adult female, it's about 50 to 55%. And in an old-aged female, it's about about 40%. Why are the percentages decreasing when one is increasing with age? So you need to understand that the body fluid decreases as a person is increasing in age. Okay, so that's how it goes. What are some of the factors affecting the total body water? They vary, depends on the body fats. Okay, like in so this one, it simply means that depending on the body fats, a person who has a huge amount of fats in them, they have a little amount of water in them. So in here we have infants. Infants, they tend to have about 73% of the total body water. Then in male adults, it's about 60%. Female adult, it's about 40 to 50% of the total body water, because the body has got fats in it. Then old age also, the body fluid goes up to 45%. Now let's look at the composition of body fluids. So composition of body fluids, we have electrolytes. What are electrolytes? Electrolytes, these are charged particle ions that are dissolved in the body fluids. An example of electrolytes that dissolves the ions, we have the major positive ions, which are called the cations. These include sodium ions, potassium ion, calcium ion, and magnesium ion. Then the major negative ions includes chloride ion, bicarbonate ion, phosphate ion, and sulfate ion, and other inorganic acid and fluids, which are the electrolytes, the charged anions as well as the cations. So composition of the body fluids. So in here, you are looking at the plasma, which is a typical body fluid. So plasma consists of glucose, bicarbonates, potassium ion, calcium ion, chloride ion, water, which is hydrogen, and the hydroxide ion. All right, so now let's look at the composition of the body fluids. So composition of the body fluids, where we have the cations. These are the metals. The cations, that is millimole per liter in plasma, interstitial, as well as the intracellular matrix. So sodium, we have 142 millimole per liter, that is in the plasma, and 139 millimole per liter in the interstitial, and 14 millimole per liter, and in the intracellular matrix we have about 140 millimole per liter. Then for calcium, in the plasma we have about 1.3 millimole per liter. In the interstitial we have 1.2 millimole per liter. In the intracellular we have 0 millimole per liter. Okay. Then magnesium, we have 0.8 millimole per liter in the plasma, and we have 0.7 millimole per liter in the interstitial. And in the intracellular matrix, we have about 20 millimole per liter. Then the cation, millimole per liter. Like for chlorine, we have 108 in the plasma, and in the interstitial, we have about 108 millimole per liter, and in the intracellular, we have 4.0 millimole per liter. Then for bicarbonate, we have 24.0 millimole per liter in the plasma and 28.3 millimole per liter in the interstitial. And then in the intracellular matrix, we have about 10 millimole per liter. Then proteins, we get to have 1.2 millimole per liter, that is in the plasma. And then in the interstitial, we have 0.2 millimole per liter. And in the intracellular, we have 4.0 millimole per liter. Then if the imbalance, so if there is any imbalance, this one simply means that it will result into a disease. And disease, these will include the renal failure as well as dehydration. Now, what is the importance of the body fluids as well as the electrolytes? The importance of the body fluids and the electrolytes is that, number one, it helps to maintain the extracellular fluid volume, which is critical in the maintaining of the blood pressure. So this one is very critical in the maintenance of the blood pressure. Then the extracellular fluid is also important in the osmolarity, that is maintaining the amount of water in the body, which is just the primary importance in the long-term regulation of the extracellular volume. Extracellular osmolarity, that is maintained mainly by sodium chloride balance. Okay, so sodium chloride balance is mainly done in the renal system. So the intake is about 10.5 gram per deciliter, and the output is about 10 gram per deciliter in urine. So fluid compartments, they have three major fluid compartments. Okay, so you need to understand that there are three major fluid compartments. The first one is the intracellular fluid, which is the ICF, that is the fluid within the cell, are also known as the cytosol, which is just the cytoplasm. Then the extracellular fluid, this is the ECF. This is the fluid that is found outside the cell. So the fluid that is found outside the cell, we call it extracellular fluid. And there are two major kinds of extracellular fluid, which includes, the first one is the interstitial fluid, that is the fluid surrounding the cells, and the plasma is the fluid component of the blood. So we have the plasma as well as the intracellular compartment and the interstitial compartment. Okay, so now let's look at the fluid compartment. So fluid compartment consists of the extracellular fluid and the intracellular fluids. The extracellular fluid gives us the plasma, the interstitial fluid, as well as the transcellular fluid. So we have the transcellular fluid that is emanating from the extracellular fluid. Then the transcellular fluid includes, these are the fluids that are found in the cerebrospine fluid, the intraocular fluid, the pleural fluid, the peritoneal fluid, as well as the synovial fluid, and the digestive secretion fluid. Now, looking at this interstitial fluid, that like within the cell, we have this fluid called the interstitial fluid, which is found in the extracellular fluid as well as, so these are the fluids that are found outside the cell. And then we have the plasma, just as we can see on the diagram here. Now, how is the distribution of the body fluid? So the distribution of the bodily fluids, we have most of the water is intracellular. Most of the water is intracellular. What do I mean by this? So most of the water is, the total body water is about 60% of the total body weight of a 70 kg adult person. So if you do 60% of 70 kg, it's going to give you 42 liters of body fluids and 50% of the body weight in an adult female and 50% of the body weight in an adult female. So in an adult female, we consider the 50% of the total body weight in an adult female. So the percentages depends on the age, gender, and the degree of obesity. Now, this brings us to the volume of the body fluid in a 70 kg man. So a 70 kg man has the total volume of 52 liters, and the intracellular fluid consists of 28 liters throughout the 2/3 of the total body weight. Then the extracellular fluid has about 14 liters throughout the 1/3. So in here you say 1/3, that is the 1/3 of 42 liters, give you 14 liters. And 2/3 of 42 liters will give you 28 liters. Then for the plasma, we do 1/4. So we say under plasma is 4 liters throughout 1/4 of the extracellular fluid. Now, the total body water. So in the total body water, we have the extracellular fluid and the intracellular, the extracellular fluid. Here we have the intracellular as well as intercellular, which include the interstitial, intracellular as well as the blood and the interstitial. Now, what are some of the measurements that are used to measure the body fluids? The indirect method can be done by the indicator that we call the dye solution technique. So this one follows the principle that you have to select a suitable dye for a radioisotope. We have V for volume, which is V fluid, and A for the total amount of the dye used, and E, which is the amount of the dye excreted or rather lost. Then C is just the concentration. So the formula goes like V, which is the volume, V equals A minus E over C, which is V, the volume of the fluid the volume of the fluid is equal to the total amount of the dye used minus the amount of the dye excreted or lost over the concentration. So that's the formula there. So calculating the compartment fluid volume, we use volume is equal to volume B is equal to volume A multiplied A over volume B. I'll give an example. If a 1 ml of a 10 milligram per ml solution is injected into a fluid compartment, and the final concentration is 0.01 milligram per ml of volume of the fluid compartment. So this one is going to be like volume B is equal to, remember, volume A multiplied by volume concentration. So the volume is about 1 ml multiplied by 1 milligram per ml over 0.01 milligram per ml. That is the concentration. When you multiply, this will give us 1,000 mils. That's the volume. Okay. So mass and concentration are the indicators that are known before. So this works only if the indicator is uniformly diffused and only into the measured fluid compartment, and if the indicator itself is not metabolized or rather excreted. Okay, so the normal body fluids, we have extracellular and the intercellular fluid. Okay, the dye injected. All right, so this brings us also to the volume of the measurements of various body fluid compartments. We have intracellular fluid, which is the ECF, which is the plasma volume. The intercellular fluid, which is the total body fluid, has the extracellular fluid, which is the volume that is found outside the cell. So volume measurements of the various fluid compartment, we have the dilution principle, which is the total body water substance that is used, where we use what we call the deuterium oxide. So deuterium oxide, that is the D2O, and we also use titrated water, antidipyrine, antipyrine, as well as aminopyrine. So volume measurement of various body fluids, we have extracellular fluids we use, substance that are used. We have two major types that are the saccharides. So saccharides, for example, we have glucose, we have sucrose, inulin, as well as mannitol. Then diffusible ion, for example, sulfate, we use sulfate sodium, as well as thiosulfate, bromide, and the chloride. Okay, so fluids of the measurements. Fluid of the measurements of various fluid compartments. We have the body fluid using the Evans blue, as well as the radioactive labeled, which is 125 high albumin. So the formula here that is used, it is the total body volume is equal to the plasma volume minus the total body volume is equal to the plasma volume over 1 minus the hematocrit value. Now remember, hematocrit value can be measured by the centrifuging. So hematocrit value, you can only get that value from centrifuging in the outer centrifuge machine. Okay, so the criteria for a suitable dye. So some of the criteria that can be used for suitable dye: number one, you must be able to mix evenly throughout the compartment, and you should also consider non-toxic, and you must have no effects of its own on the distribution of the water or other substance in the body. Either it must be unchanged during the experiment, or if changed, the amount changed must be known. So if there is any change, the amount changed must be known. Materials should be relatively easy to measure. Now, what are some of the factors affecting the body fluid compartment as well as the electrolytes? Number one, we have physiological, which is under physiological, we have adipose tissue. So adipose tissue can affect the body fluid compartment. Remember, when these adipose tissue, these are the tissues that accommodates fats, they accommodate lipids, and when the lipids increases in the body, guess what happens? The body fluids reduces. Okay, sex also affects the body fluids. This tells us to say that males tend to have more body fluid compared to the female. Okay, then age also plays an important role in the body fluids. Okay, so age is also one of the contributing factors that affect in the body fluids. Okay, so age, we had to notice in our preamble to say babies tend to have more body fluids, and an adult tends to have a little or few amount of the body fluid. So this simply tells us to say that when a person is increasing with age, there is the decrease in the body fluids. Then also pathological. This one includes dehydration as well as overhydration. All right, okay, so yeah, so these are the pathological factors. Then what is an osmo? An osmo is just the molecular weight for a solute in grams, and it is divided by the number of ions or particles into which it dissociates in the solution. Okay, so that's on the osmo. So we have the Sila-Jangan confuse, okay, where we talk about osmolarity and what osmolarity is all about.